Archimedes of Syracuse, c. 287 BCE c. 212 BCE, was a Greek mathematician, physicist, engineer, and inventor. His contributions to science were groundbreaking, especially in mathematics and physics. Here are some of his major achievements. The buoyancy principle of Archimedes, also known as Archimedes' Principle, states that a body wholly or partially submerged in a fluid experiences an upward buoyant force equal to the weight of the fluid it displaces. If an object is placed in a fluid, like water, it pushes some of the fluid out of the way. This is called displacement. The displaced fluid has weight, and this weight creates an upward force on the object known as buoyancy. If applications of Archimedes' principle. 1. Ships and submarines. Ships float because their shape allows them to displace enough water to create a buoyant force equal to their weight. Submarines control their depth by adjusting their buoyancy. 2. Hot air balloons. They rise because the hot air inside is less dense than the surrounding cooler air, creating an upward buoyant force. Applications of the screw, bolts, and nuts. Used to hold objects together. Jack screws used in lifting heavy loads, for example, car jacks. Corkscrews used for removing corks from bottles. Archimedes' heat ray and war machines. Archimedes allegedly designed a heat ray using polished bronze mirrors to focus sunlight onto Roman ships. The concentrated sunlight could potentially set fire to the wooden ships, causing destruction without direct combat. How it worked. 1. 2. The focused light increased the temperature of the wooden ships, igniting them. 1. A series of concave mirrors, or polished shields, were aligned to focus sunlight onto a single point. Besides the heat ray, Archimedes designed several mechanical war devices to defend Syracuse. This destabilized and sank enemy ships. B. Catapults and ballistae. 3. This created a powerful defense mechanism against the Roman fleet. These were capable of destroying ships from a distance before they could land. Archimedes' spiral. The Archimedean spiral is a curve described by the equation RABE theta. Archimedes improved catapults to launch large stones, spears, and flaming projectiles at Roman ships. The applications of Archimedes' spiral. 4. Biology. Some natural patterns, like the shape of certain shells, resemble 3. Optical discs, CDs, DVDs. Data is stored in a spiral pattern. 1. Water lifting. Archimedean screw. Used in irrigation and drainage systems. 2. Antenna design. Spiral antennas are used in radar and communication systems. The hydrostatic principle of Archimedes, commonly known as Archimedes' Principle, states that 1. Shipbuilding ships float because they displace a large volume of water. 4. Hot air balloons. Work on a similar principle but with air instead of liquid. Archimedes' principle related to center of mass. 1. Law of the lever. Archimedes stated that a lever is in equilibrium when the moments, force distance, on both sides are equal. 2. Floating bodies and stability. Archimedes' work in hydrostatics described how the center of buoyancy, the center of displaced fluid, affects the stability of floating objects. When the center of mass is aligned properly with the center of buoyancy, an object floats stably. 3. Center of gravity and shapes. Archimedes determined the centers of gravity for simple geometric objects like triangles and spheres, which was a step toward the modern understanding of the center of mass. Applications of center of mass. Balancing objects, for example, seesaws and bridges and cranes. Stability of floating objects, boats, submarines. Engineering and robotics, designing stable structures. Archimedes approximated pi, using a geometric method based on inscribed and circumscribed polygons. His approach is known as the method of exhaustion, a precursor to calculus. Archimedes' approximation of pi. 1. He inscribed and circumscribed regular polygons around a circle. 2. By increasing the number of sides, he narrowed down the range in which pi lies. 3. He used a 96-sided polygon both inside and outside the circle to estimate pi. His final approximation. 3.1408 pi 3.1429. I hope you will surely recognize my efforts for providing valuable information and will hit subscribe button of my channel.